be confused. Anyway, so we have special sequences, right?
Not series.
Okay. Were you supposed to use these?
Yes.
Because technically, in our book, you haven't learned L'Hopital's yet. Maybe just a few of you were trying to do L'Hopital's. Come back. You were able to rewrite one to be the limit as n goes to infinity of 2 times ln of n over n. True? What converges? The sequence. Nice.
I got it.
Nice. Why would I say you should also have rewritten this one to be the nth root of n all squared? Limit properties, a composition of functions. You can take f of the limit.
Wait, what?
When you have a limit of f of g, it's the same thing as f of the limit of g as long as f is continuous at each of the points in g.
Is that supposed to be like detail?
Yeah. No. Beginning of calculus. The limit properties that everyone's like, I don't care. Okay.
Back to bite.
What's it end up being? N to the 1 over n. 1 over n goes to 0. N to the 0 is 1. 1 squared is, what'd you guys get? Ah! Nicely done. Convergent.
We got there. Just
The same thing to do n to the 2 over n. Just
But as far as like, I guess technically be this. I haven't seen them make you prove a normal. They make you prove in a free response will be L'Hopital's that we're talking about soon. How about this one? Is it?
Yes.
Why?
Because it would be 1 times if there was
Yes,
a 3.
I'm saying, can you separate?
Separate.
Wait, but there's no property.
Oh, maybe that's just what you have to analyze, because the other part becomes 1. So then you just analyze what's left.
So as that one goes to 1, then any constant to a 1 over n. The confusing part isn't a constant to 1 over n. The confusing part is what happens when you have n to the 1 over n. Because technically this would be infinity to the 0, and infinity to the 0 is... Is it? But a number to 0 isn't indeterminate. Does that make sense? So that one's indeterminate. This one needs a property. This one can be common sense of 3 to the 1 over n is 3 to the 0 as n goes to infinity. Hence 1 times 1 is 1.
Oh.
We were so confident.
Oh, because we rewrote it like
3n to the 1 over n.
Yeah.
But technically the n to the 1 over n does need the property because it's indeterminate. You can't say that's 1. So your brains are making logic of the special sequences, but the problem is that logic will not always get you to 1. Or I should say the answer shouldn't always be 1. If it's n to the 1 over n, yes. But if it's something else with infinity to the 0, not necessarily. Does that make sense? Yeah. So it's more of a warning. But a number to the 1 over n is totally fine, so hence the 3 didn't mess it up. Does that make sense? How about letter D? Why?
Because when you keep going, it'll...
Why?
Because it'd be like 1, 4, 20.
Anything that's in between 1 and negative 1, it goes back to geometric sequences and when they converge. When you did limits in pre-cal without knowing it. Actually, I said you were doing limits in pre-cal, but you might not have cared, but you weren't with me. Anyway, this is very sad. 0. I know, which is also good, but besides you wishing for his death with strawberries. Coming back. How about letter E? I was roasting Maggie. She just missed it. What?
It's e to the negative 2.
It is e to the negative 2?
Yeah.
I said except for when you were wishing with his death with strawberries.
Oh.
Was it death or was it just dislike?
Strawberries, and we're like,
Oh, you were like, how many strawberries? Or something like that, I think.
How? Please explain.
Mm-hmm. Without doing L'Hopital's, because technically we haven't done L'Hopital's, if it's not property. Done. But we'll see it with L'Hopital's. So whatever's on. Wait. Yeah, because it was plus x, right? Plus x. So what's in the x spot? A -2. But and therefore the sequence converges.
I feel like it's worse when you point to us. I feel like we're like.
I know.
We're like, yeah, wait, what?
I know. It's like we're supposed to. I don't know. You guys in pressure kills me.
0.
0? What? It's 100 to the n. That's huge.
But the bottom's bigger.
The bottom eventually overtakes. Factorial will be the fastest growth, even when the base is 100 or a million or a trillion or a gazillion. What? It's just going to take a long time. It's actually a digit, I think. You should look it up in Wolfram Alpha. Equals 0. What was all of that to do? I don't know. Let's go check homework, huh? See if anything's weird. But pause. As you guys are turning to homework and getting out your colored pen, my question to you is, why is the limit 0?
Oh, I got it. Okay,
I think it was a homework problem.
0?
I got 1.
Uh-huh. Why is it 0?
It's squeeze theorem.
Squeeze theorem, because sine squared is always going to be in between what? 0 and 1.
Oh, I just said it was 0 because bottom one.
What's the limit?
I did too. Alright, I put 0.
If you take the limit of each of those pieces, 0.
I still don't know how to do squeeze theorem.
You're right.
It has to do squeeze theorem and all that. I didn't do that. I just found the limit.
I'm showing it to you now. Hello. Sine squared, isn't it? Because it's a squared, always going to be between 0 and 1? Right?
Yes.
So then what's the limit as you go to infinity of 0 over 2 to the n? 0. How about 1 over 2 to the n? 0. Oh, so if it's squeezed in between 0 and 0, what must it be going to, too? Ah.
Would it be wrong to say bottom one so it's 0?
Technically, yes.
It's wrong or
It's not a proof. It's a mathematical trick, and your mathematical trick is right. But if you were to actually explain in an AP, it would not work.
No one asked me to do this on the FFA.
Probably not. But just in case.
I don't want to squeeze anything.
Depends on L'Hopital's, though. All right, tell me what numbers we got. I'm so sad right now. Actually, the last time this happened, I think it showed up a day later, and I'm not sure where it came from. I'm hoping that happens again.
Are these the answers?
Yeah, these are all the answers, though. Help me out. What's our first number?
1.
Okay, sorry. What's our first even?
Sorry, I'm so sorry. 16.
16.
It's been a while.
Can we go over 20?
16 is the first even, though, right?
Oh,
But yeah, we'll get there. 1.5, 25.629. 1.5 to the, or times a to the n minus 1. Or it could be 3 halves. I would have done 3 halves. And then 3 halves to the n minus 1.
Okay.
Was 22 next?
Yes. I'm not really good at what I noticed. How do you? It took me a while because like I thought it said fifth number, but it's the second and 7th number.
Oh dear.
Change the whole game.
Okay, you guys can just tell me the questions, right? I don't want to go through selecting my country.
I don't really have enough spaces then because I did that too.
What was given in number 22? What were the terms?
Second and 7th.
What was the second term? Third, fourth, fifth. 16?
Oh, I just couldn't remember how to do it.
Is that right? Second and the 7th?
Yeah.
So a sub 2.
Yeah.
I think that's 6.
Oh, because I separated that one and I didn't. I don't know, because it's a. There you go. 8, 4, 2, 1. Oh, that's easy. Okay, so 8, 4, 2, 1. Negative, positive, negative, positive, negative. Oh, so your r is equal to negative 2? Yeah. I only did that because I saw 16 and I saw 2 and I said they had a common base. And I'm like, oh, I bet if it's geometric, it's dividing by 2 backwards or multiplying by 2 forwards. But the other way to do it is a sub 2, which is negative 1/2, would equal a1 times r to the 1. And then 16 would equal, because it's a sub 7 or the 7th term, a sub 1 times r to the 6th, right? And you could actually do like a substitution-y thing, or you could do the really snazzy, like you divide both sides, because it's totally legal to just divide whole equations by each other. The same way you can add whole equations to each other. And negative 1/2 divided by 16, ew. I like 16 divided by negative 1/2. But those reduce. That ends up being 1 over r to the 5th, and this ends up being negative 1 over 32. So I flip them both, and I 5th root both sides, and I end up with r is equal to negative 2. You could do that too.
Well, not the negative 1.
Or you can make up your own formula and say, hey, to get to the 7th from the 2nd, wouldn't there be 5 jumps? 1, 2, 3, 4, 5. Oh, I could just say something to the effect of 16. Aww. 16. A sub 7 is equal to negative 1/2 a sub 2 times 5 of those r's. You could do that too. Could it be times r times r times r 5 times? You can make your own formula, because then you get negative 32 is equal to r to the 5th, so r is equal to negative 2.
I'm writing that down right.
Isn't that nice?
Can you always do that?
If it's geometric or arithmetic, because it's a constant pattern, yeah.
That's good.
Isn't that nice?
That's very nice.
But it's you thinking creatively outside the box and being like, I can make my own. Is that what you did?
No.
What was your hand, though? You had a question.
I just had a question. I was trying to do it. I'm pretty sure I did really wrong.
That's okay. What were you trying to do?
It's kind of like how you like say the distance formula.
Okay.
So for the top, I did like 16 minus 1 negative 1/2, and then I put it all over. And I was going to do a number of jumps, but
That would be good for arithmetic, not geometric. Arithmetic adds a constant amount every time, and so those amounts could be seen as distances, whereas geometric is multiplying. It's compounding differently.
okay, so basically I just found like the average jump between all of them because you have the same amount. So if you divide it.
So she was thinking finite distances, which would be good if it was addition. So arithmetic, yes. Geometric, sadly, no. Because every time you're increasing by the same ratio, but different distances. Does that make sense? Got it. But good idea for arithmetic. That's exactly the way. Okay, Riley, we good? Oh, sorry. Then you go ahead and plug into your a sub n formula, which would be your a sub 1. So you'd have to go back or divide by negative 2, hence 1/4 times r to the n minus 1. And they rewrote it because they're spiffy. Hold on, pause. Do you guys understand the rewrite? Good skill for the future. Let's talk about it for 1 second. Remember how in derivatives and integration we had to not only take them but also simplify them to make them match? What'd they do? Yeah, you do. Or you will. Couldn't we do that? Pause. Does that make sense? Separated the negative from the 2. P.S. This whole negative 1 to a power thing is pretty common in series. So we're looking at them in sequences. Don't worry. So if we separate the negative 1 from the 2, they're both going to have the exact same power. The 4 is a 2 squared. The reason we do that is because we have a 2 to the n minus 1 minus 2. Sorry, positive 2. Does that make sense? Or you could also have negative 1 to the n minus 1 times 1/8 times 2 to the n. That one's kind of awkward. Because you could have done 2 to the negative 3. Like you could have pulled out this 1/2 and made it 1/8. It's just awkward writing as far as for a sub n notation. That one's better. It's okay. You didn't need to know it. I'm just showing you how it works. Does it make sense that it works? Exponent rules. Ugh, they're a killer. What's the next even?
26.
26. He looks like that. Swoop, there he is. Why isn't it connected? And if you connected it, why are you wrong? Can you plug in a 1.5 to an a sub n formula? Sure. But is there a term there? No. Why not? There's a first term, and there's a second term. But what is there not? Anything in between. Remember, the n stand for the number of terms. Is there a 1.5 term? No. If 3 have this term, no. There's a first term and a second term and a third term. These are called discrete, ooh, good math term, functions. Discrete, separate points, not continuous. The only x's, the only n's are whole numbers, whole positive integers. I probably shouldn't use whole and positive. No, whole and integers in the same sentence. What else? 34. 0. Converges and the limit is 0. Why? Bottom wins. Huh, that one's not too bad. They just compared the highest degrees. That's all right.
Why did they do that?
40 even? Technically, they're looking at the right end behavior model, which is the same thing as the highest degrees of both. Sorry, 40 even? Diverges. It diverges. Why? Because it can't make up its mind. It's not getting closer to any single one.
Oh wait, 39 is the answer to 1?
Yeah.
I think it's because it oscillates.
Why does this one not diverge? Squeeze theorem? Yeah.
That's what I thought. I was thinking of like the graph. And I was like, okay. So since I thought about it, but in class you had said something about like.
But it's okay, if it was just the sine one, if it was just this, it would not exist. But since it's over, and we learned this, it was a while ago, but you can change limits to infinity to limits to 0 by flipping everything. So what you're doing is you're basically transforming it and saying let n equal 1 over x. And so if n equals 1 over x going to infinity is the same thing as, wait, equal 1 over x. Over n makes more sense. So if I do 1 over n as n goes to infinity, x is going to go to 0. There we go. And so then x can be 1 over n. It's like a little quick u sub. And this one's much easier to see. A, it's a special limit. B, we could use L'Hopital's. C, as you're oscillating, this is going back and forth, but this is continually, it's confusing. I wouldn't say it necessarily makes sense, because you have sine of 0 over 0, so you have 0 over 0. I think L'Hopital's is the best way to make it make sense. But that's why it's in this homework before L'Hopital's, is because it is a special limit. It equals 1. We memorized it. But technically it's squeeze theorem, because you could say that this is in between 1 over x and negative 1 over x. But as x goes to 0, that would be infinity. That doesn't help. Oh, it would be dne. 1 over x and negative. As you go to 0, the limits don't agree, so it would be dne. That's why squeeze theorem doesn't work. Yeah, you need L'Hopital's. Or memorizing the special trig limit. What's the next one? Any more evens?
She said if you switch it, if you make 1 over n equals x, and then you put like it goes in the numerator.
You do like a substitution-y thing.
Yeah. And then it'll match to the special.
The other way of...
Because there was like an
Here?
n in the front, and then that becomes 1 over
Here?
x, and so that goes into like sine over x, and then the 1 over n in the parentheses becomes x.
You can think of it, 1 over n is u, because we have the limit as u goes to 0 of sine of u over u. So if 1 over n is u, then And 1,
I get what they did after. I just don't know why the 1 over n is on the bottom. I'm not.
multiplying by n over 1 is dividing by the reciprocal. Lo siento. Dividing by its reciprocal. Yeah. We'll review that more when we do L'Hopital's. Sorry, number 54. Shoop, 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 shoop. E.
Wait, you skipped 44, 46.
Oh, lo siento. I asked for the next one. Okay. 44.
That's the one we did. This right now.
0. Oh, we already got that one. Yeah.
That's the one we're supposed to squeeze.
Yeah. Squeeze between 0 and 1, and then the whole thing is going to be 0. Number 46.
It's, yeah, 46.
C. 48. Do you need that one? A.
45 is B. You just plug in the first term of each one and then.
But one of them was.
You silly goofs. Check your odds. Is the next one 54?
Yeah.
E. Any more evens?
No, that was
Okay.
Could you explain this one?
Oh, 54? Sure. What was the given? This one?
Yes.
Is equal to -1, like this expression? Okay. To say something about evens and odds? Oh, that was just a sub n. Got it. Okay. If you guys were to actually start plugging in stuff, did you actually start doing that? Did that help? A lot of you guys would look at this and say, hey, the limit is 3 converging. But the problem is the limit isn't 3. The limit is technically 3 and -3 because every time you have an odd number being plugged in, this is going to be a negative, and every time you have an even number plugged in, this is going to be a positive. So what's happening? They're in a disagreement.
So if it was 1 to n, then it would just be 3. That's it.
If it was just 3n minus 1 over n plus 2, yeah, it would just be 3. But since you have that -1, it's oscillating. And since it's not going to 0, remember, the only time alternating signs can converge is when they're agreeing on 0. Otherwise, it's going to be disagreeing. Maggie?
Can we go over 45 and 47?
Yeah.
Because I got them confused, but I'm confused as to why it's wrong.
We're given graphs.
Yeah. Well, there are graphs or tables. And so for 45, like if you stick in the numbers, like you get the ones in the table. Unless I can count, but I was just doing my math.
Because they both started with 2. Is that correct?
Yeah, but then if you go to the second term, it should be what? It's 3 over 2, which is 1.5, right?
Did you keep going, though?
No. Because the other one's 3
Remember first 4 terms.
Oh, but in the other one, it's not 3 over 2. The first term is...
No, if you plug in 2 to 47 and to 45, you get 3 over 2. Because 2 plus 1 is 3 over 2, and then 4 minus 1 is 3 over 2. But that's a good word to the wise. Sequences can start off being the same and then diverge, and then be different. Okay. Any other questions? Odds, evens, going once, going twice.
Wait, actually, 35. Did you already do this one? Oh, 35? Yeah, it was.
Hey, it's just like the one we just went over because of the negative sign.
Oh, it's just the same exact.
Right.
Got it.
Right.
Oh, wait, it diverges?
Why?
I don't know.
You missed us explaining whatever the one was that we just did. 54. It's going to diverge because the limit does exist of the non-alternating sign. If you just look here, the limit is 1, but then it alternates. So between 1 and -1, is it ever agreeing?
Okay, yeah, I had divergence.
Oh, you're good.
I explained it to Arne. I don't think I explained it right, but I did something.
Good. I wanted to know if it's the same exact logic.
Okay.
Is that one considered an exponential? Like if it's like the -1 to the n times whatever n minus 1 over.
No, we call it an alternator, basically. If it's just -1.
Okay.
Yeah. Okay, I mean, technically it would be exponential, but with a 1 is exponential functions. Exponential functions, okay, over here, needs to quiet down a little bit. Exponential functions have bases other than 1 and 0, technically, because 1 to the and 0 to the is pretty boring and doesn't follow exponential growth in any way, shape, or form. So for our purposes, for sequences and series, -1 to the n, n plus 1, 2n plus 1, 2n, whatever they want to do, we're just going to call it an alternator. There are other alternators too. Sine pi n, nope, that's boring. That's just 0, 0, 0. Sine pi over 2n is 1, -1, 1, -1, 1, -1. Cosine of pi n is 1, -1, 1, -1. There are different ways to get alternators, but just a quick reminder of indeterminate forms. All of those, if you get them, you don't know what it is. Unless it's one of the special converging sequences that we just wrote about. Not series.
I was gonna say it, but I was like, it's
I
too
know, it
late.
was a little bit awkward, yeah. I went right past it. So why am I showing you all the indeterminate forms? I could show you, this is a struggle. I could show you the ones that are determinate, but I think for the most part we should be good on that. The problem that we get stuck on is the indeterminate ones. However, I'm not afraid that you don't know how to do L'Hopital's. I'm a little concerned that you're going to get stuck here and there on the hard ones. But what I'm more concerned about is when I went to the AP workshop and they said they took off a lot of kids' points because they didn't show the following on their L'Hopital's part of an FRQ. Ready? We're changing our L'Hopital's rule.
So are we going to write down the determinate forms also?
I mean, it's something like 2x plus x squared as you go to infinity is going to be infinity. Like, so positive infinity plus more infinity is more infinity. That's about as basic as they are.
Like infinity plus infinity.
That one's indeterminate because we don't know which one's stronger. Yeah, but yeah.
And then there was one where they kind of infinity,
Yeah. Would still be negative infinity. So that'd be the constant. Yeah. What's missing? 0 to the infinity is missing because that would be 0. That's the only one I can think of that we wouldn't know. 1 to the 0 is easy because that's 1. I think the only weird one that you wouldn't be as sure of is 0 to the infinity is 0. But anyway, does this look like L'Hopital's? And the answer should be yes, because this is literally the L'Hopital's card, the forever card from last year. But there's a big old awkward space, right? Why? I need you guys to make a special note of the if. F and G need to be differentiable. The if, F and G need to be differentiable. And the second if, the indeterminate, need to be true in order to use the L'Hopital's. F and G need to be differentiable on the interval everywhere, all around C except maybe at C. And the indeterminate form. And the limit as x goes to C of G is 0. Or DNE. Yep. Why am I saying or infinity? Because either it's 0 over 0 or it's infinity over infinity. Why are the AP guys getting mad when kids just write 0 over 0? The limit doesn't equal that. The work shows that it would be, but they're like, no, it doesn't equal 0 over 0. It equals something else, and you're about to go find it. So technically, you're giving us a statement. So if we were to do this following example down here, where I would normally say, hey, 0 over 0, and there were lots of different teachers there, and like, well, we have our kids do this to try to do that. One of them said, yeah, we have our kids do equals 0 equals 0. And I'm like, that's great, because you're showing the idea. And they're like, nope. So. You can just make it an endeavor if you want. We're just not going to put a number on it, or you could go back and change your forever. The long story short, we need to add in this step. And technically, we should have always been saying this. I just let you guys shortcut it. But the problem is they are saying basically they love to put this on an FRQ. And if they put it on an FRQ, they need your logic to be seamless and to be perfect. I have an example right here, and I'm going to show it to you as to how they grade it. But for this example right here, we would have said equals 0 over 0, true?
Yeah.
Now, is it good to still think in your head 0 over 0? Yes, but what are we going to do? Limit as x goes to 0 of e to the 2x minus 1 equals 0. Limit as x goes to 0 of x is equal to 0. Are these both true statements? Yes, and when you put them together, 0 over 0. Keep going. Without us saying that this equals 0 over 0 is technically not true because that is not an answer.
So they graded it like this on our last, like, our without telling us.
So then coming back. It never was. But it looks like it's going towards 0 over 0, which means we have to go looking for the real answer.
So
The real answer is not 0 over 0.
should we write it like that? 0 over 0?
Yes.
Okay.
That's
What is the AP want?
They want us to be better.
He wants to suffer.
They want us to waste time.
You have to basically write the indeterminate form, but not 0 over 0.
You have to show that it is indeterminate without putting an equals 0 over 0 next to that. Does that make
Wait, so what did you...
No equal sign.
no equal sign. You can write 0 over 0, but no equal sign.
So what did you mean when you said it never...
What if I did like an arrow? Like
Because the
arrow?
answer never was 0 over 0. 0 over 0 was an indicator to go looking for an answer. So when we put equals, we were saying a false statement, along with many other calculus students all over the
So
country.
like, whenever I do a problem and I don't mean to say
World.
equals, I do like an arrow.
That's what I
Could I do that too?
They're like, it's not a...
That one's better, but they might have still not given you the points for showing all of the work for this. Does that make sense? They wouldn't have taken off the point for the arrow, but they might have given you the point for stating. Yeah. Equals
So we have to write that every single look test problem.
on a free response.
So for our homework, how is that working?
It's up to you. Because on homework, just don't write equals 0 over 0. Don't write equals infinity over infinity, right?
Just do the arrow.
Can I write equals now?
Yes.
Yes.
Why would they come up with this?
Because the people that are behind the scoring, the grading, being the head of everything that's done are college professors, and coming from this, like, your proofs need to be seamless or else you throw the whole thing out. If you have one inconsistency, it's not a proof. Yeah.
So you can do like the limit of whatever 0 over 0, but just don't put equals.
Don't put
and then,
equals.
and then you don't have to write.
You have
still
to,
have to write it.
yeah, you have to write both.
Both.
Let me show you. So the FRQ, one example that they had,
I want to know who makes these decisions. Is it South Lawn? Is it South Lawn himself?
okay, check it. No, it's not South. I met the head guy, and he's smart. Coming back. Okay, this is L'Hopital's. Why? That's going to be 0. That's going to be 2. Going to h of x around x approaching 1 and 2 and 3 and 4. 1 and 2 and 3 and 4 is 0. Why am I confused right now? Is this h of x? Oh, 4, sorry, is 1. So 2 times minus 2 is 0 over 0. But did they allow you to write 0 over 0? What's the limit of the numerator? What's the limit of the denominator? Hey, we can use L'Hopital's. Technically, in last year's your FRQ, they also took off if you didn't write something about the differentiability, sadly. But then you say, hey, let's go, done. Now, I do have like the actual notes as to when they gave you 0.0 points or 1 point, 1 point, and then some different possible solutions and how they scored it. So we'll peek at that tomorrow. Play with L'Hôpital's. Technically, we won't grade it until Tuesday. Sound good? All right. Bye, guys. I would start it, but we're not grading it till Tuesday. We'll peek at the AP guys' stuff tomorrow.